Good morning, everyone, and thanks so much for joining the seminar this morning. I'm Taryn Murray, and I'm an instrument scientist based at the South African Institute for Aquatic Biodiversity, and I'm currently managing the Acoustic Tracking Array Platform, which is a nationwide network of equipment called acoustic receivers, which monitors the movements and migrations of tagged animals along the coast. Before I introduce our speaker this morning, just some basic house rules. Attendees can make use of the Q&A function to pose questions during the talk, but the questions will only be answered at the end of the talk. With that, it gives me great pleasure to introduce Godfrey Padare this morning. Godfrey was actually my first ever student doing his master's degree on the movements of spotted grunter in the Goko Estuary in the Western Cape. Since then, he's taken up an internship with the ATAP team, where he's been roped into all sorts of things like swimming in muddy estuaries, trying to find missing receivers, to pulling seine nets as part of other students' projects, to counting urchin spines under a microscope. Today, he'll be talking about his recent adventures to the Mkambati Nature Reserve as part of an Eastern Cape Parks and Tourism Agency field trip. Thanks, Godfrey. Over to you.
Hey, everyone. Not sure if you can see the screen that I'm sharing, or you're actually looking at the Zoom one. Not sure which one you're looking at. Can you please confirm?
All good, Godfrey. We can see your presentation.
All right. Thank you so much. As Dr. Murray has already introduced me very well and talked about my adventures with my internship and my studies, I'm Godfrey, and I'll be taking you through my estuary monitoring field trip, which was done in September. So basically, it's done by the Eastern Cape Parks and Tourism Agency in conjunction with the Mkambati Nature Reserve staff. And basically, this particular section of the project is focusing on the Pondoland Marine Protected Area. And also, I've included South African Institute for Aquatic Biodiversity due to my involvement with the field trip this time. So basically, it's a biannual survey. So basically, it's two of them, one in March and one in September. So I got to tag along for the September one. Giving you an overview of the area that was or rather, the area that was the focus of this particular survey. It is the Pondoland Marine Protected Area, demarcated there by the blue area there. So Mkambati Nature Reserve is the reserve that is flanked by the Mtentu Estuary and the Msikaba Estuary, and also did Mntafufu and Mzimvubu close to Port St. John's. What did we do? So basically, we used an Aquatrol 400 multi-parameter probe to collect physical-chemical characteristics for each of the 4 estuaries, which I mentioned before, as the Mtentu and the Msikaba, which are part of the no-take category, where there's no fishing activity that is allowed. There are some activities that are allowed, but it's just fishing activities that are not allowed. Mntafufu Estuary, where it's a controlled zone, and the Mzimvubu Estuary, where it is open. Just some basic information about the actual instrument that we're using, the Aquatrol. The probe has a smartphone app and an interface that allows for easy calibration and viewing of the data in real time. For this particular survey, we focused on using the probe to look at the maximum depth, salinity, pH, conductivity, temperature, dissolved oxygen, and the visibility using a Secchi disk. Also the total dissolved solids, but for the purposes of this presentation, I'll only be focusing on the maximum depth, salinity, and pH. Just to give you a view of what the estuaries look like, this is the Mtentu Estuary. As you can see, there's a massive sandbank almost closing up the mouth, but at high tide, actually, the water does cover that area and mix well with the estuarine water. You have the Msikaba Estuary, which is just on the other side of the Mkambati Nature Reserve. So on the north side you have the Mtentu. On the south side, you have the Msikaba estuary. Funny thing about that, you can actually see in this previous image, you can actually see there on the top right, you can actually see the reserve, like the offices. But in order for you to get from here, the Mtentu estuary, to go and sample in the Msikaba, you have to drive all the way out to Lusikisiki and then drive back out again to Msikaba, because there's no access between these 2 points here. Yeah, so that was quite interesting for me to find out that we're going to be driving 7 hours to a place that I was looking at from the houses. Then you have the Mntafufu estuary, which is quite a beautiful site. Then you have this rock formation right there closing up the mouth. But on the left side there, going up onto the hilly mountains on the side there, and that's where the ocean meets the estuarine water. And then you have the Mzimvubu estuary, where there's a lighthouse just up top, and on the right side of the screen, then you will see there's the town there, the town of Port St. John's. What did we do exactly? So basically, we measured the values at each GPS waypoint, which was predetermined, from the surface, which was 0 meters of the water column, to the very bottom of the water column every 50 centimeters. So it was from 0 meters, which is the surface, 0.5 meters deep, 1 meter, 1.5 meters. So we're looking at all those parameters that I mentioned before, the temperature, pH, dissolved oxygen, all those factors. This is just a picture showing that we actually had to like make a plan on the field trip, where we had to actually physically mark on the cable or the cord of the probe, so that when you're letting the slack go, you can then tell that, okay, we've reached this point, so you stop, and then you actually confirm the depth using the display on the smartphone device, on the app, because it also shows the depth. And then max depth is when the probe hits, the actual sensor hits the bottom, and then you know that, okay, so this is the maximum depth, and then you capture that information. Just some general information about the Mkambati area. The climate in Mkambati is mild and subtropical with relatively high humidity. And most of the rain falls during spring and summer, September to February. And I can confirm that this is correct, because for 2 out of, I think, 2 or 3 days, we got rained on heavily on the field trip. So it was quite interesting trying to write on and not make sure that the paper that we're writing on didn't get wet with a pencil. And then it's also characterized by open grasslands dotted with indigenous forest patches, swamp forests, and it's flanked by the magnificent forested ravines of the Msikaba and Mtentu rivers. And some beautiful gorges there, the Msikaba Gorge and the Mtentu Gorge. Yeah, but I'm not sure, I didn't actually get pictures of that, sadly. But yeah, so the grasslands and also covered with some grazing herbivores. I'm not sure if you can see them there because they're quite camouflaged to the environment. They really blend in. Couple of zebras on the drive within the reserve. And also some scenic features include the forested ravines, swamp forests and splashing waterfalls, and some interesting cliff faces, as you can see there, including one of the few waterfalls in the entire world that falls straight into the sea, which is, I think, 16 kilometers north of the Mntafufu estuary on the coastline. So yeah, this is just more pictures of the beautiful scenery that you get to see when you get there. So this is part of the Mtentu estuary. And just to give you an idea of how little access you have between points or to get access to the actual estuary. If you notice, this is the left side. The picture on the left there is the left side of the river, and adjacent to that on the right side, that's what the other side looks like. So you really don't have any access unless you have a boat where you launch it on a relatively flatter surface, and then you can actually go and see these areas. Some of the uses of the estuary that are permitted, kayaking is one of those activities that are permitted here. And as you can see, there's some kayaks parked there by the bank. And yeah, you can also go sightsee the estuary and the scenes using a kayak. Other uses that are not permitted, for example, fishing and hunting. So on the top left, you can see a gentleman there in a blue jacket with a red cap or red hat. He was actually fishing when we were driving up, and that is not permitted. And two gentlemen there on their little red paddle boat and their dogs. We assumed they came from hunting in the reserve, which is also not allowed. They were quickly told to vacate, and yeah, thankfully they did. The situation did not escalate. So yeah, from driving up and down the rivers, one of the sites which really caught my eye and the damage that sometimes is done by natural events. This is in the Mtentu River or Mtentu Estuary, where there's massive mudslides that actually destroyed some part of the forest there. And moving on to general knowledge of estuaries in South Africa. So the salinity levels are generally highest near the mouth where the ocean water enters, and lowest upstream where fresh water flows in. So I need you to keep that in mind when we're going through all of this. And normally salinity levels have a depth profile. So closer to the surface, you have generally lower salinity than at the bottom of the water column, basically. And also knowledge of pH is important because most aquatic organisms are adapted to live in solutions between 5 and 9 pH. And the pH in an estuary tends to remain constant because the chemical components in seawater resist large changes to pH. So in this particular survey, what did we find? We found that there is some human activity in the no-take estuaries of Mtentu and Msikaba. This can be attributed to the long history of usage by the local surrounding villages. So outright enforcement of the no-take status can be a very sensitive issue because sometimes, or if you are not careful on how you enforce it, people may feel disenfranchised and therefore have a negative view on the protection measures that you are trying to show that they benefit their communities. And also impacts of this sparse usage are still unassessed. And also that the depth profiles of the Mntafufu and Mzimvubu estuaries have been severely impacted due to sediment deposition, where some sections have been reduced by up to 2.5 meters, which is quite significant. And also the mouth condition of the Mzimvubu has been known to close and open intermittently. And with this particular survey, it was quite constricted. And this has caused the upper 1 meter of the water column to be hyposaline, which means that the salinity levels are approximately less than 2 parts per thousand, which is very low, considering that it is an estuary and it's normally brackish water, which are around 30 to 35 parts per thousand. And this was exacerbated or made worse by the heavy rains during the KZN floods, which happened in April of 2022. The rainy days during sampling could have also skewed the results. However, the quantity of rain and the depth to which the salinity was hyposaline suggests that larger quantities of fresh water were deposited into the estuary, which is characteristic of the April floods. Now, just showing a quick map of the Mzimvubu sites where we sampled. So site 1 is closest to the mouth, going up all the way to site number 6. And if you notice, there is kilometers in between the sites. So that's the distance between each site. So from site number 1 to site number 2, it was 1.7 kilometers. And site number 2 to 3 was 1.8 kilometers and so on. Some sites were actually close to 4 kilometers. From 3 to 4 there, it's quite a large stretch. And the total extent of monitoring of the Mzimvubu estuary is approximately 14.3 kilometers, which is quite extensive. The results of the survey, or some results, this is the depth profile. where the maximum depth from September 2021, which is the survey that happened, the second survey in 2021, basically. You can see that the maximum depth there from site 1, which is site 1, 2, 3, 4, 5, 6, from the left going to the right. And from top to bottom, the top is 0 meters, which is the surface. And then going down, that's how much deeper, that's deeper into the water column you get, right? So the red one there will be the September 2021 sampling, which saw a max depth at site number 4 of 4 meters. And all the other sites were actually quite deep at around 3 and 2.5 meters. But in March, where there were heavy rains prior to the floodings, you can see that the sites, each site, were approximately 1 meter deep. So there was a lot of sediment deposition there where the fresh water came in with all of the sediment from upriver and around the catchment. But the good news is that in September, again, when we went and sampled, when I went and sampled, when I was part of the sampling, the system seems to be recovering basically the same to its non-flooded state, basically. Yeah, I think that's the word that I'm going to go for, non-flooded state. So if you look at the profile in September 2021 and September 2022, you can kind of like see a trend where the 1 and 2 are not that deep, and then number 4 is deep. And then all the way upriver, slightly less deeper than the ones closer to the mouth. And then in September, that's kind of what is happening again, compared to the March 2022 one, where all of them were shallow. And then the salinity profile. So each box there, each grid will be the sites, and then the depth is from the left to the right, and then salinity is moving from 0 at the bottom and potentially to 35, or supposed to be 35, because like I mentioned, it's an estuary where the salinity profile would be 30 to 35. But from what we see is that in September, the salinity was low, and then once you get deeper into the deeper water column, then the salinity increases all the way up to around 25, 24. But in March, the first site, this is first site. So site number 1 is closest to the mouth. So right where the ocean meets the estuary. And then you're getting salinity readings of 0, 0.5, which is quite low, very low, in fact, for a brackish environment, or a supposedly brackish environment. So for the sites number 2, 3, 4, all the way to 6, all of them were basically showing very low salinity readings. Based off of this, looking at it, just from my opinion, is that in September 2021, it should have been higher salinity levels, but it seems as if like the Mzimvubu is quite fresh, or fresh water rather, like less saline than you would expect. The pH profile, which was quite jarring for me to look at, is that in September, which is the red bar, so the deeper you go, that's from left to right, the deeper you go, the pH will change. But at site number 1, you see that it's 8.8 and it drops down to 8.4 and goes back up to 8.8 with the depth. So it's one site, but the pH varies with each depth, like the value. And then when the floods came in, the pH basically moved from 8.8 to 9.3. So if you know the pH scale, these are significant or huge differences in pH, which could affect the animals that are found there, and also obviously the flora as well. But with the September 2022 survey, we see that it's also stabilizing and going back to its near natural condition. Site number 2 as well, same thing, but at least it was less drastic. And for site number 3, it was very drastic, 9.6 and 8.8, which is 0.8 and on the pH scale is a big difference. But also the estuary is stabilizing and going back to its natural condition, because you can see the blue line there indicating that moving from the green flooded state to the non-flooded state now, where it's recovering, it's actually coming back. And with sites 4, 5, and 6, there is relatively less drastic changes to the pH scale, basically. Yeah. So this is just a picture showing some of the conditions that we had to work under. So if you noticed in the other past slides, site number 6 has less depths and stuff like that. But in the depth profile, I actually included site number 6 with some other information. That's because the probe that we're using is a cable. So once you put it inside the water column, and when the current is high, it gets dragged all the way back. So you don't actually get accurate readings for that. So hence we're not able to collect more data on site number 6 because the current was very high at that time when we were actually doing that. And also just big ups to the ladies and the teamwork. It really goes to show that science is for everybody. So why are we doing this and what's the significance of all of this? So basically the ECPTA is the designated management authority for all provincially declared nature reserves. That includes the marine protected areas and the land protected areas. And this is an ongoing project by the ECPTA to build and maintain profiles on the estuaries under their care. And according to the National Protected Area Expansion Strategy of 2016, the main priorities were the Eastern Cape. In the Eastern Cape were the Pondoland, the Greater Baviaanskloof, the Sunshine Coast, and the St. Francis region, just to name a few. So there are a lot of areas that are being targeted for this type of, and the Amatole Reserve actually, where the information you now build up and maintain profiles on the estuaries to see when events or what events are doing to the estuaries, like the health of the estuary, for example. And this is to assess the effects of natural weather events such as floods and droughts on the health of the estuaries that we value so much. And monitoring of these highly variable environments means management will be more effective because the policies will be rooted in up-to-date information. So you're not depending on 2 years or rather information from 2 years ago, because some other events may actually alter the state of the estuaries, and also checking for pollutants and stuff like that. But I didn't include the other side, the water quality side. I just focused on those 3 that I mentioned. Thank you so much for listening to me talking about my adventures. I really appreciate the chance to share with you. So these are just pictures of the staff that were helping out. So on the top left there, you have Mkambati Nature Reserve staff, and bottom left, you have Karen Bullock. And yeah, that's me on the boat with Mr. Machain, just enjoying the views between sites. Yeah, I'd like special thanks to Ms. Bullock from ECPTA, Mr. Machain and his staff, Ati Nolucha, Pumlani, Tandega, and Zozo from the Mkambati Nature Reserve. And a special thanks to Dr. Murray for indulging me with these adventures. Thank you so much.
Great, thanks very much, Godfrey. That was great. It's always interesting hearing what happens on these research, these monitoring trips. So it was a great talk. I see that George Branch has his hand raised. Lucky, are you able to help us there?
Hello, Lucky. Can you hear me all right?
Yes, we can, George.
Thank you. First, my apologies. I missed the initial part of your talk because my Zoom was insisting that I upgrade when I tried to link in. So sorry about that. But I did have a question. From the section of the talk that I did here, I picked up a lot of very interesting information about the physical changes that have taken place. But I just wondered, is there any ongoing monitoring in terms of the biological system to examine whether these physical changes had significant effects on the biota of the estuary or not?
Okay, all right. So as far as I know, there hasn't been anything done, but I could find out for you and then give you a feedback on that. Yeah, because it costs a lot of money and time and effort. And I think with the limited resources that the ECPTA is working with and their staff, I think that they're doing a good job of it to at least have the baseline information to see that, okay, there is some physical changes to the estuary. Then I think purely from a research perspective, it would be nice to have the biota as well being looked at to see what's actually happening.
Yeah, I can just add to that. I don't think it has to be that onerous a task to do that, because the physical is ideal for getting a quick picture because you can get the information almost instantaneously. But in terms of biological changes, I think if you had a longer term monitoring program in mind,
yeah,
you could examine those things at quite long-term intervals. Let's just say, for argument's sake, 5 years. So you don't have to go through the expense and the time of doing something like that every time, or every time something like this happens, but at least you have a baseline to work from that you can examine periodically. Thanks, Lucky.
Thanks, George. Just a comment from Rudy van der Elst, very nice. And then a question from Carla, Godfrey. Cool talk, Godfrey, and great pictures, thank you. The pH data you presented was interesting, as levels you presented are really quite high for seawater, which is usually around 8.1, and even estuaries. Also with flooding, one would expect pH to decrease rather than increase. Did you notice any blooms or high levels of phytoplankton productivity in the estuary that may have caused these high pH levels?
Okay, thank you for your question. We didn't notice any large blooms in the Mzimvubu. We may have just missed them because the water is very, the visibility is very low. Maybe we just missed them from the very murky waters, because the visibility, I think, was 0.02 centimeters or something like 0.02 meters, I mean. So it was very, what's the word? Turbid, yes. So we may have missed it. So there may be other factors at play that would have affected the pH to actually go up all the way like that. But from what I saw in the data is that it's seemingly stabilizing for whatever reason. So maybe the thing that caused the spike in the pH, whatever it is, has been flushed out of the system or is slowly being flushed out.
Yeah, Carla says, thank you. Would like to chat to you about this further if you're interested. Cool, thanks, Carla. Just a follow-up question from Rudy van der Elst. What happens to the data which will become increasingly important and relevant over time? How much does it link to biota, such as grunter?
Okay, thank you for your question. Okay, so for my presentation and for how much I was allowed to present here, I think you may have noticed an asterisk on all the data that I included and that I presented. So the data is actually property of the ECPTA, so it's not SAIAB owned. So I can't really speak to the storage methods and what they're planning to do with it. I think it's just a matter of letting people know that this is being done. And from my side, I can follow up on that and find out what are the plans. And you can also actually follow up for yourself to find out where the data is being taken and how much processing are they planning to do, because it is quite invaluable information that is being gathered here.
So maybe you can keep doing this, Godfrey, and then you can give us feedback in another talk in like 2 years' time.
Yes, exactly. So I hope they're watching and they're like, yes, okay.
Karen, I see you're still online, so just a heads up. Godfrey will be involved. Do we have any other questions? Yes, George. Lucky, are you able to help with unmuting George?
Yes, I think just
There. Okay, I've unmuted myself. Thanks. I was very intrigued in your data to see that immediately after the flood, the depth profile indicated a huge decrease in the depth,
Yes.
which you then showed subsequently recovered in the later September survey. Now, I'm kind of surprised because I would have imagined with a flood of this magnitude that the depth would have initially increased with scouring taking place. What you seem to be indicating is that sedimentation is initially taking place, decreasing the depth. Am I interpreting this correctly?
Yes. So another thing to note is that in the Mzimvubu, there are dredges all, like, I think every kilometer or so for the first 6 kilometers of the estuary. So I think maybe that could also be part of it, where more sand has been deposited in and then they're actually taking it out, and the depth profile, the recovery is basically a direct result of them taking the sand out, if that makes sense.
Yeah, that does make sense, and it's an interesting wrinkle. I hadn't appreciated that hedging was going on. Thanks.
A question from Alan Whitfield. Any plans to address the sedimentation issues in the Msikaba and Mtentu estuaries?
Are there any
plans to address the sedimentation issues in Msikaba and Mtentu?
Oh, okay. Yeah, no, I honestly can't answer that question. I think Karen would be a better person to actually approach with that. Yeah.
Karen has popped her email address into the chat for those that are interested. She is running the project, so always in charge of the long-term monitoring. So if you do have questions and are interested, please do reach out. There's also a question from Mohammed Bayat. How's it, Godfrey? Lovely talk. You said the 2 sampling sites could be seen from each other. So I think those were the ones with where you were looking at. Was it not more feasible to get there by boat instead of driving the 7 hours by road? Just curious on that one.
Oh, okay. Okay, so like I said, with the limited resources that the staff have, there are no big boats that can actually go out to sea, which is the only route that you'd probably take, which is from the Mtentu to the Msikaba. There are no big enough boats to actually drive out via that way. So we do have vehicles, so we make do with what we have. So then the drive was the option. The boat that we're using, I'm not sure if I included a picture of it, but it is an Isuzuma. It's a 4-seater little rubber ducky, which is quite nice to ride on, but would not survive out in sea.
Would be a bumpy ride.
A very bumpy ride.
Great. Do we have any more questions? Don't see anything in the Q&A and nothing popping up in the chat. Nothing else. Oh, I see George. Thanks, Lucky. Regards. I see a hand. I'm struggling to see who it is. Hang on. Let's see. Alan, we have a question from you.
Can you hear me?
Yes.
Okay. There was a study done by Rhodes University scientists in the 70s on a submerged waterfall in the Mzimvubu. Burke Hill, I think, was the leader of the the team, and it was published, I think, in Marine Biology. This is the deepest point, or the deepest estuary in South Africa, the submerged waterfall was. I was just wondering whether this submerged waterfall still exists or whether it's been filled in with sediments, and what the characteristics of that profile are today compared to what it was in the early 1970s. It would be something that could give you an indication of how much the bottom topography of that estuary has changed over the last 40 years, almost 50 years.
Oh, okay. That's actually interesting, because there is a site, I think Msikaba site number 3 or something, where the maximum depth the last time that they did a survey was 18 meters, 16 or 18 meters, I don't remember. So that would actually explain the underwater waterfall, basically, submerged waterfall. Yeah, for this site, using the instruments that we were using, that cord or the cable wasn't long enough to actually get to the bottom. So we only did, I think it was 8 meters deep it was. So yeah, it would actually be interesting to go back with instrumentation that is actually suited to deal with exactly that, to say, okay, we're going to look at the maximum depth at that site and then see what the effects, or the changes rather, that have happened over the years.
That's excellent. Just one other comment. We did gill netting sample there in the mid 1970s, very brief. I think it was one night, and I've never recorded so many, or such a diversity of kingfish and mullet species in a single net as was recorded in the Msikaba. It was an incredibly rich system at that time in terms of diversity and also relative abundance as well. And one wonders whether that's still the case or not. Unfortunately, it was, as I say, just a 2-day sampling, which doesn't give you a comprehensive view of the whole system either. But my impression was at that stage, compared to other systems like St. Lucia and that this was a very, very unique system and an important system. And I think the Mtentu system subsequently has also been shown to be a very important system as far as kingfish are concerned, because they gather there at certain times in large numbers and large sizes as well. So the biological components of those estuaries haven't, as far as I'm aware, been well studied, but the biological components could be very important from a biodiversity perspective for South African estuaries, and then that hasn't really been documented up until now.
You make me want to come into the field, Alan, figure out what's happening there. Then I don't see any other questions, just some comments, Godfrey, about great talks, lovely talks, informative, fascinating. So yeah, I think people enjoyed it. The talk will, one more from Dina. Hey Godfrey, lovely talk. Do you know if the ECPTA do this kind of survey, do these kind of surveys in all their reserves or protected areas? And if yes, how can one get involved or even get access to some of the data for research purposes?
Okay, thank you, Dina, for the question. So the ECPTA does do this kind of survey. As far as I know, it's the Amatole, Pondoland, what's the other one that?
Duesa.
Duesa, yes, Duesa as well. Not sure if they do it for all of them, but I know of those ones. I think Karen Bullock sent a link on email. So in order for you to see how you can get involved or get access to some of that data, then you can actually contact her, because she's the point person to talk to about the ECPTA data stuff. Yeah.
The talk is available on our YouTube channel, so please feel free to visit the NRF SAIAB YouTube channel if you've missed the talk or want to revisit anything that Godfrey has talked about today. But yeah, people definitely seem to enjoy it, Godfrey, so that was great. Well done. If there are no other questions or comments, I think with that, we could probably end the session. Feel free to reach out to Godfrey about this more. Karen did pop her email address in the chat. So if you do want to chat more about ECPTA or how to access the data, please feel free to reach out to her as well. But otherwise, I think we have reached the end of the talk and the session. Thank you very much to everybody joining online. We had a very good turnout. I think we had over 50 people at one stage. So excellent turnout for the talk this morning. And thank you very much, Godfrey, for taking time to prepare the talk and for being a willing participant of my suggestion of giving a talk. So thank you very much. And thank you everyone online. And hopefully we'll see you all at the next SAIAB seminar. Thanks very much.
Very much.